All right, testing. Okay, hello. We are going to do 7.5. And yes, I have my sunglasses on. And you have to get your regular glasses fixed. And the only extra pair you have are sunglasses. Yeah, look like this inside. So just ignore me or laugh at me. I don't care. I'm laughing at myself. All right, we're going to do 7.5. 7.5 is basically application of everything we learned in Chapter 7. So application always means word problems, okay? So let me read this to you very carefully so you can hear it. It says, Marissa's car uses 10 gallons of gas to go 210 miles. So she uses 10 gallons, and she can go 210 miles, okay? She has 5 gallons of gas in her car right now, and she needs to know how much she needs to add to that to go 640 miles. So she wants to go 640 miles, and she already has 5, but she doesn't know how much more she needs to add, okay? We're going to set up a proportion where you put, in proportions, you have to stay, if you put gallons on top and miles on the bottom for the first one, you have to put gallons on top and miles on the bottom for the second one. You have to stay in the order that you put it, okay? So 10 gallons gets us 210 miles. So in order to go 640 miles, I already have 5. How much more will I need to add? So this represents how many gallons. This is gallons. This is miles, and this is miles. Now, something you need to remember, and maybe you don't, is something called the means extremes rule. When you have a fraction equal to a fraction, this times this always equals this times this. It's called the means extremes rule. Okay, so I can say 10 times 640 has to equal 210 times 5 plus x. Well, either way, I have an equation, equal sign, variable, I can solve. I multiply and I get 6,400 equals, I multiply and I get that plus 210x. All right, I can move that over. And I get 5350 equals 210x. I divide by 210, and I get x equals, you round it off, 25.5. So it will take approximately 25.5 more gallons besides the 5 that they had in order to get 640 miles. And that's the question, and there's your answer. All right? All right, let's do another one so you can see how this works. See the pattern, okay? Let's look at, it says on a map of the United States, the distance between Seattle and Durango is 4.125 inches. So here's Seattle, and here's Durango, and on a map, it's 4.125 inches, okay? It says the two cities are actually 1,238 miles apart. So on a map, it's 4.125 inches, but it's actually 1,238 miles apart. Now, on the same map, what would be the distance between Chicago and El Paso if they're actually 1,606 miles apart? So between Chicago and El Paso, how many inches if they're actually 1,606, is that right, miles apart? So set up a proportion. Miles, inches, inches, miles, it doesn't matter. I'm just going to go miles inches. So miles, 1238, it's 4.125 inches. So with 1606, how many inches? Means extremes rule. This times this, 1238x has to equal that times that. Which means I have to get my calculator out. So, what do I have? 1606 times 4.125 is 62475. Now divide by 1238. And you get x is, this means approximately 5.4. So it's approximately 5.4 inches apart between Chicago and El Paso to represent 1,606 miles. Okay? All right. That's one type of application. Let's look at another. What if I had something that said this? Letitia and Kareem are working on a neighborhood cleanup. Kareem can clean up all the trash in the area in 7 hours. So Kareem can do this in 7 hours. Letitia, on the other hand, can do the same job in 5 hours. Letitia is faster. How long will it take them if they work together? So how long if they work together? Now, this is not where you can set up a proportion, okay, because you just have hours. You don't have two different pieces of information. You have Kareem does it in 7, Letitia does it in 5, okay? So think about, this is how you do it. Kareem can do one job in 7 hours. Letitia can do one job in 5 hours. They want to know how long will it take if they work together, okay? Well, actually, let me set this up for you. We have Kareem, we have Letitia, and the rate that they work, remember how rate that they work times the time that they work is going to give me the part of job that they do, okay? So Kareem is 1/7, Letitia is 1/5. How long if they work together? Well, that means, this is the rate I just put here. So now I have to do times time, okay? This is the rate, now times time. Are they going to work together? Yes. So are they going to both work the same amount of time? It didn't say one started before the other, it just said if they work together. So their times are the same. We just don't know how long it is, okay? So you get 1/7 x, and you get 1/5 x. Now, what you do is you take both of these fractional pieces and you add them together to equal one whole job. He does 1/7 of the job, she does 1/5 of the job. How long will it take for them combined to do one whole job? Okay? All right. Well, now we're back to, I want you to look at it as x/7 plus x/5 equals 1. We're back to the way it was when we had in 7.4, where we had to find a common denominator. What is the common denominator for 7, 5, and 1? It's 35. So we have to multiply. What I'm doing is I have a fractions equal to something. I need to solve for x, and I need to get rid of the fraction. So I'm going to multiply each piece by the common denominator. Remember how we did this? Each piece by the common denominator. All right, so what do I get here? 7 becomes 1, 35 becomes 5, x times 5 is 5x. Plus 5 becomes 1, 35 becomes 7, x times 7 is 7x. equals 1 times 35 over 1 is just 35. So I get 12x equals 35. Divide by 12. And you basically, if you think about it, 35 divided by 12 is 2.92 hours. Okay, remember everything is in hours, so it's 2 hours, and then they might want you to find out what 0.92 minutes is, or they might be able to let you, but if you do, you need to find out what 0.92 minutes is. So what's 0.92, oops, you do 0.92 times 60, and that'll give you, so times 60, no, sorry, divided by 60. No, 92% of 60 minutes, yeah. 0.92, I was right, 0.92 times 60. Ah, I just pushed the wrong button. Multiply it, you get 55. So it's 2 hours and 55 minutes. Whenever you have this, just multiply by 60, and it'll give you how many minutes. All right, let's try another one like this. Let's try another one like this. All right, let me read you one here. Butch and Peggy want to pick up the mess that their grandson, Grant, has made in his playroom. Butch can do it in 15 minutes, and Peggy can do it in 12 minutes. How long will it take them if they do it together? So Butch, he can do it in 15 minutes. Peggy, she can do it in 12 minutes. And remember, rate times time equals the part of job that each one is doing. So they're both going to work together. So we get x over 15 and x over 12. They want to know how long will it take if they work together. So x plus 15 plus x over 12 equals 1 over 1, the whole job. Okay, so all we do, multiply by the common denominator. What would the common denominator? We can just say 12 times 15 is 180. I believe 60 would be the common denominator, but it's up to you how you want to do it. Uh-oh. That was weird. Okay, so 60 actually would be the common denominator. So we're going to multiply each piece by 60. I'm going to write the 60 on this side since my face is there. All right, 15, 1, 34, 5, 60, 4. So 4 times x is 4x plus 12, 1, 65. 5 times x is 5x equals, and then it's 60 times 1, which is 60. Combine like terms, you get 9x equals 60. Divide by 9, and you get 6.666, which is 2/3. So it's 6 2/3. This time it wasn't hours, was it? Think about what they said. They said that they were doing their work in 12 minutes and 15 minutes. So this is just 6 2/3. It was in minutes, so we don't have to transfer anything. It's already in minutes. Okay. All right. 7.5, that's what this is. It's all application, okay? It's all application. So let's see if we can get to 7.6 here. The 7.6 is still a little bit like 7.5 in terms of application, but it's dealing with what we call variation. Okay, direct variation and inverse variation. That's what we're going to be talking about. Now, What do I mean by direct variation? Well, directly proportional. That's another word for it. So you either have directly varied or directly proportional. Either one of those means the exact same thing, okay? Direct is y equals kx. Inverse is y equals k over x. Now, let me just talk about direct for a minute. Does it not make sense to say, if you work at a job where you are paid an hourly wage, then it's safe to say, listen to me when I say this, that your paycheck is directly proportional to how many hours you work. Does that make sense? You work 3 hours, your paycheck's small. You work 30 hours, your paycheck's bigger. Okay? Now, looking at this formula here, y would represent how much you make, your paycheck. X would represent how much or how many hours you work. K is always what we call the constant. And yes, I'm spelling it wrong. It's constant is spelled with a C, but I write it with because it's always a variable K. I'm trying to help you remember it. The constant. What is it that's always the same? How much you make, how many hours you work gets multiplied by what? What's always the same? Your hourly wage. That's the constant, okay? That is the constant. So let me read to you something. Abby is paid an hourly wage. No, that's not what I want. Here, I want this one. Hooke's Law. Okay, I'm going to write this out because it's very important that you see this. Hooke's Law, blah, 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 states that the distance a spring stretches is directly proportional to the force applied. Now, that is your key. You see this directly proportional? We know we're going to be using this model, y equals kx. Now, just let me finish and it'll make sense. If a force of 150 newtons stretches a spring 8 centimeters, how much force or how much will a force of 150 newtons stretch the spring? All right, now, very important that we look at the fact that the word is directly proportional. Now, we are going to use the y equals kx model, but I want you to see what comes before the word directly proportional and what comes after the word directly proportional. It says Hooke's Law states that the distance a spring stretches. So the distance a spring stretches. Now, if I'm looking at y equals kx, whatever comes before the word directly proportional goes here, and whatever comes after the word proportional goes here, okay? So look back up. What came after? Force applied, okay? So I am going to change my y to the distance a spring stretches, and I'm going to change my x to the force applied. I'm just changing my variables so that they match up to what I'm looking for, okay? And this is what I do. I need I'm going to have to use this formula twice. All right, let's read what it says. I'm going to have distance, force, and my constant, distance, force, and my constant. First it says, if a force of 150 stretches a spring 8, okay, how much will a force of 150 stretch a spring? All right. I took everything I needed to out of my word problem. Now, using this, D equals KF, I have a D, I don't have a K, and I have an F. But can I solve for K? I sure can. I can divide by 150, and I can get K is equal to 0.05. Or 4. We could just, let's just reduce it by 2. 4 over 75. Okay? So K is 4 over 75. Now remember I told you K is a constant. It doesn't change. So it can be moved over here as well. Now, using D equals K times F, I don't know my D, but my K is 4 over 75, and my F is 150. So I can solve for D, which is what they wanted. 75, 152. 4 times 2 is, I'm sorry, what did I do wrong here? I wrote 150 twice. That was silly. You see where I put, it's 150 here, and I put another 100. This is supposed to be 400, not 150 again. So this time, the force, if it's 400, no wonder I came up with the same answer. Wow, I hope some of you guys saw that. Was thinking to yourself, what is she doing? All right, let's start. D is going to equal, what's our K? 4 over 75 times force of 400. So D equals, if you multiply all this out, you get 64 over 3, or 21 1/3 centimeters. Because 75, you could do by 25, that would be 3, and that would be 8. See, no, that would be 16. See, 1, 2, 3, yep, that would be 16. So then 4 times 16 is 64, 3 times 1 is 3. There you go. Well, now that I've completely confused you, let's do another one, okay? Let's do another one. Phone went off. We're sitting here. This phone has been going all day long. Okay. Move this over. Let's do another one. What if I had here we go. The volume of a can of pork and beans. So the volume of a can of pork and beans is directly proportional to the height of the can. To height of can. If volume is 300 inches cubed, when height is 10.62, find volume when height is 15.92. All right, directly proportional. So we are using y equals kx. But what comes before the word directly proportional? Volume. So I'll make a V. K doesn't change. And then what comes after directly proportional? Height. So this is what I'm going to be dealing with. Volume equals K times H. Now, if the volume is 300, when the height is 10.62, okay, find the volume when the height is 15.92. We still don't know K. All right. Using volume equals K times height, volume is 300, K I don't know, height is 10.62. Can I divide and solve for K? Yes, I can. So 300 divided by 10.62 is 28.24. So 0.25. So K is 28.25. And remember, K is a constant. It doesn't change. So it's 28.25 on that side. Now, can I solve? Do I have enough to solve for volume? Yes, I do. Volume is equal to 28.25 to K times the height, 15.92. So volume is equal to 449. Make sure I got the right answer there. Yep, 449.7, so about 450 inches cubed, because that's what the volume was inches cubed. Okay. All right, let's try another one. Let's try if they talk about inverse. Okay, same idea, but this time, what if the problem said the frequency of a vibrating string, so frequency of string vibrating is inversely proportional to its length. If a piano string is 2 feet long, so if a 2-foot string vibrates 250 cycles per second, what frequency? Frequency is the vibrating here. What frequency would a 5-foot string have? All right. Inversely proportional. Y equals K over X. Again, though, same thing. What comes before the word inversely proportional? Frequency. We're going to give an F. K is the constant. What comes after the word inversely proportional? Length. That's your X. Okay? Now, knowing that, this is how we're going to do it. Frequency equals K over L. I need an F, I need an L, and I need a K. I need an F, I need an L, and I need a K. All right, what does it say? If a 2-foot string length vibrates 250 cycles, how much frequency or what would it vibrate if it was 5 foot long? So we are solving for this. Now, I can find my constant out using F equals K over L because I know F is 250. I don't know K, but I know L is 2. All right, which means to get rid of the 2, I would multiply. 2, I'd multiply, and I get K is 500. K is 500, and it's the same on both sides, so I can put that over there. And now I can solve for this F. F is equal to K over L. So F is equal to 100. So the frequency of a 5-foot string would be 100. We're starting to see this? All right, there's one more little twist they might put in there. And I'm going to read one to you and see and point it out. For a body falling from rest, the distance the body falls varies. Okay, so distance body falls varies directly, which is the same as directly proportional. They sometimes use this, they say it this way too, as the square of the time. Then it says, if object dropped from 576 feet high and hits ground in 6 seconds, how far did it fall in 4 seconds? Now, varies directly is the directly proportional, which is the y equals kx. But I want you to notice what comes before the word distance. We can do that. What comes after the word? The square of time. So we not only put a t here, but we have to square it. Sometimes there'll be little variations like that. Okay? It just adds a dimension to the formula, that's all. Okay? So distance equals k times t squared. Now, I need a d, I need a t, I need a k. I need a d, I need a t, I need a k. What do they tell us first? If an object is dropped 576 feet, the distance, it hits the ground in 6 seconds, how far did it fall in 4 seconds? Okay? All right, we can find our k by using distance equals k times time squared. So distance 576 equals k times 6 squared. So 576 equals k times 36. Divide by 36, and you get k equals 16. So k is 16, it's a constant, so it's the same over here. So now I can use the formula again to solve for my distance. So distance is equal to 16 times 4 squared. So 16 times 16, which is 256. So it fell 256 feet in 4 seconds. Okay? And that's 7.6. That's the last thing that we are doing in this class. Look at that. All right. You need to finish up this week's work. You have 2 quizzes. You have an exam. I wish you the best of luck, and I'm here if you need me for anything. All right.